We have studied the theorem of derivatives of Laplace transform or multiplication by powers of t, and we have proved this theorem for the two cases. Case number 1, when n is equal to 1. Case number 2, when n is equal to r. Today we are doing some questions, some problems based on the derivatives of Laplace transform or multiplication by powers of t. Our first question is, calculate the Laplace transform of t raised to power 2 cos 80. So this question we can do with the help of the article, that is a theorem of derivatives of Laplace transform or multiplication by powers of t. In this case, let us suppose ft is cos 80. That is, it is equal to Laplace transform of ft will be equal to Laplace transform of cos 80. And we know that Laplace transform of cos 80 is s upon s square plus a square. We have already proved it. Suppose it is fs. Now, Laplace transform of t raised to power n ft, we have already proved it is minus 1 raised to power n d n fs upon dsn. In the theorem of the derivatives of Laplace transform or multiplication by powers of t, we have proved this relation. That is, the Laplace transform of t raised to power n ft is equal to minus 1 raised to power n dn fs upon dsn. If we use this relation, we get Laplace transform of t square cos 80 is equal to minus 1 whole square d2 fs upon ds square. Here simply in place of ft we are writing cos 80. In place of this n, power is 2. So with the help of this relation we can write this thing. Now if we solve it, it will become d2 upon ds2 s upon s square plus a square. That is d upon ds. It will become s square plus a square whole square, and here s square plus a square minus s into 2s. That is d upon ds. This is nothing but a square minus s square upon s square plus a square whole square. If we solve it, we'll get minus twice s s square plus a square minus a square minus s square twice s square plus a square twice s divided by s square plus a square whole 4. That is, here s square plus a square is common, and here what you get, minus twice s cube minus twice a square s minus 4a square s plus 4s cube divided by s square plus a square whole 4. If we solve it, it will be minus, this is twice s cube minus 6a square s upon s square plus a square whole cube. That is twice s square plus a square upon s square plus a square whole cube. So this is the result. So by using the theorem of derivatives of Laplace transform or multiplication by powers of t, we can solve this question, that is t square cos at, and the result is the Laplace transform of t square cos at is twice s square plus a square upon s square plus a square whole cube. In the similar way, there are so many questions, there are various types of problems. You can solve it by using this theorem, that is the derivatives of Laplace transform or multiplication by powers of t, and these questions are as follows. This question is, find the Laplace transform of t square sin at. Next, find the Laplace transform of t cube e raised to power minus thrice t. Next, find the Laplace transform of t plus 2 whole square e raised to power t. And fourth question is, find the Laplace transform of, there is a new type of question. So in the series of these 3 questions, there is one special question, find the Laplace transform of 1 plus t e raised to power minus t whole cube. So these are 4 questions, and you will have to do these 4 questions with the help of the theorem, that is the Laplace transform of derivatives or multiplication by powers of t. Thank you.